All right. So we're talking about a new topic, and it's one of the most important topics in all of physics, and that is the idea of energy. In our textbook, our introductory physics textbook, they talk about energy in mechanics in chapter 7 and 8. So we're kind of maybe chapter 8 a little bit more. The idea of energy for us is as a way of studying motion. And we already have one good way of studying motion. We have the idea of forces, and forces directly affect an object's acceleration. And then we went through a lot of kinematics to understand what acceleration does to an object. But there are other theories, there are other ways of explaining an object's motion. And in introductory physics, we have a theory of energy, which is pretty important. And we also have a theory of momentum, which is pretty important. So forces, as it turns out, don't just affect an object's acceleration and its motion directly. Forces also transfer energy. And they do that in the form of work. So those are two of the words that we're going to use a lot. Work is energy transferred by a force, and energy itself is something an object can have. And then later we'll get to talking about momentum and impulse, and forces also contribute an impulse to an object, which changes an object's momentum. So energy is, I like to think of it as a currency of the universe. And I think this will go smoother if I bring up the notes in another screen. There we go. And I like this analogy between energy and currency because we have a lot of mental intuition about money. We deal with money every day, and we are very concerned about money because we need it to do things. So we spend a lot of our effort trying to figure out how to get more money so that we can do more things. And I want to be able to latch into that intuition that you already have in your head and think about how energy is. The analogies is that they both involve money can take the form of cash money in your hand. And we have a form of energy that is very analogous to cash money in your hand. That is called kinetic energy. And kinetic energy is energy an object has just because it's moving. Any moving object has kinetic energy. And in order to make an object move, you have to somehow get it some kinetic energy. And here's the formula for kinetic energy. It's 1/2 mv squared. One important note is that energy is not a vector. We studied forces and accelerations, and we're going to study impulses and momentums, and those things are vectors. Energy is not a vector. So energy is just a number. And as a number, it can be positive or negative, but kinetic energy, as this special form, is always positive. And one of the other interesting things is that kinetic energy doesn't depend on the components of velocity, it just has the magnitude of velocity here. It doesn't care the direction of velocity. So that's the first analogy between energy and money, is that kinetic energy is like cash money. It's money that's actually in use, actually being carried around. So the next thing that you care about with money is that you use it for transactions. And there's a form of energy that is kind of like a transaction. it's not really a form of energy itself, it's a way of changing energy, and that is work. Work is the amount of energy transferred by a force. And in a transaction, in a money transaction, you often think about the amount of money that's being transferred. So we'll talk more, well, you'll see in the lessons how work is related to the amount of force and the distance traveled. So it actually requires a delta x in order to have an x direction force transfer some energy. So I can exert a force in the x direction, but if that force doesn't cause any motion, it's not transferring energy. On the other hand, if I exert a force and it causes motion, that's actually transferring energy. That's doing work. And then transactions, money transactions, change the amount of money somewhere else. And energy transactions change the amount of energy that you have. So this is the work kinetic energy theorem. And it just says energy is the amount of work. Now, there's something to be said about the signs, the SIGNs of work. We usually talk about incoming energy as being positive work. So when you have a slow moving object and you make it go fast, the act of going faster means it has more energy. That's positive work. That's positive delta K. Many of you are engineers who will have to take thermodynamics. And in thermodynamics is not necessarily the gas at the center of your engine. Your object of concern is something cool down a house, or you're trying to heat up something. So from that perspective, when the gas gives your object energy, that is what you think of as positive work. And in thermodynamics, positive work is the output of energy by the system at the center of the analysis. And it's a little strange in thermodynamics because the thing you care about is over here, but the thing you analyze is over here. So that's why thermodynamics uses the opposite direction for the definition of positive work. When you take thermo, keep that in mind, that we're always concerned about what is doing energy and what is the work being done on the thing being having work done on it is so then what else do we do with money that's similar to something that we can do with energy? We store money in bank accounts. Kind of similar to a bank account, and that is called potential energy. And it's abbreviated with the letter U in. So I'm going to keep using that symbol, capital U, for like thinking about holding your money in your wallet versus holding your money in a bank account. The bank account is just as safe and just as useful as the money in your wallet. It's just that you need to do a little internal transfer first before you can actually spend the money. A lot of what I guess the modern tech companies, Google, Apple, and Samsung are trying to do is make it easier for us to spend our money out of our bank account and give it to retailers to get stuff. But there's still a translation step in between. The money is being translated from bank account money to transferred money on our behalf by the electronic systems in the background. Think of your receive a large amount of money, cash scratch-offs, and the store had to give you $200. Your net worth has increased by $200. And you can think about the money you have in the bank plus the money you have in your pocket as like your total liquid cash net worth. Well, we have a form of energy for that too. We call it total mechanical energy, which includes both the kinetic and the potential energy. And when you go to the bank and deposit your $200 from that scratch off, it doesn't mean you don't have that money anymore. It's still your money. It's just in the bank instead of being in your pocket. You can go right outside and get a different $200 from the ATM almost right away. So transfers between your own cash in your wallet and your own cash in the bank account are very easy to do, and you don't lose any money in the process. So we can do that with objects and energy. We can transfer energy between kinetic energy and potential energy, K and U, back and forth very easily without any loss of energy. And when we transfer energy between K and U, this is a special kind of work called conservative work. It means we can conserve our total amount of energy in the process. Not just the total amount of energy in the universe, but the total amount of energy that we have accessible to us. Other forms of work, such as gaining energy from outside, are called non-conservative work. And one of our concerns with energy analysis is going to be figuring out whether a particular energy transfer is from a conservative force or a non-conservative force so that we can handle it in the most straightforward way possible. I have one more analogy between money and energy, and that is that we do have non-liquid assets in the financial world. You can buy stocks and bonds and all kinds of securities. And the analogy between money and energy continues here because we have other forms of energy. So we can gain or lose cash as we transfer money between our wallet and the stock market. A lot of people this year have really taken a bath on the stock market. Hopefully, we'll be able to get things back in gear, and people who are depending on that for their retirement money will be able to get the money when they need it. But money transfers to and from non-liquid assets, you can end up gaining or losing money. With energy, we can only really lose energy. And when I say that we can lose energy, I'm only saying that we can lose energy that we have access to. So, so maybe I have some U, some potential energy. And I turn that into thermal energy. may later want to turn that thermal energy, which maybe is in the form of um, steam or something like that, into usable mechanical energy. And this is a job for a device called an engine. In thermodynamics, an engine is anything that turns thermal energy into mechanical energy. And the problem with engines is they cannot be 100% efficient. Engines are always losing some of the energy. And one important point about energy is that when we do lose energy, that energy, we refer to it as lost, but it's only lost to us. The energy is still there somewhere in the universe. It's just that we don't have control of it anymore. It goes away, and um, we can't make use of it to make things move or bend or break things anymore. So as you study the textbook, as you study the notes that I posted and the videos that I posted, maybe you'll even study other people's explanations, such as Khan Academy or something like that. Try to keep in mind this analogy between energy and money and think how the calculation that's being done fits in and is analogous to some kind of financial thing that could be happening. Because money is a lot more tangible than physics quantities to a lot of people, and that might end up helping you have more intuition about what's going on.